So for distance, speed, and time questions, you're always going to start by setting up a chart. And in the textbook here, it has set up a chart for us, and we want to enter in all the data that we know. So in this question, Mario drove from Edmonton to Grand Prairie and back, a distance of about 360 kilometers. So the first thing we know is the distance, and we can fill that into our chart. Mario's average speed was 30 kilometers greater on his return trip than on his trip out. His total driving time was 10 hours. Determine Mario's average speed on each leg of the journey. So we don't know how fast Mario is going. This is where we introduce a variable. So I don't know the speed on the way there. I'm going to call that x. And on the way back, I don't know that speed either, but the question gave me a comparison. So once you pick one variable, you can't introduce another variable in this chart. We wanted to do everything in terms of x. And they tell us this is 30 kilometers per hour faster. So that speed will be x plus 30. Then you complete the chart with formulas. We know, and again, this is the formula that I would say is easiest to remember, because you know speeds. Speed of a car is in kilometers per hour, which is a distance over a time. So you have that formula just by knowing what a speed is. Then you can take that formula and rearrange it. In this one, we're going to need to use the time rearrangement, because we don't know the times, but we know that time is distance. So I can write in here, I'll go back to black, is 360 over x, and this time would be 360 over x plus 30. Next, step 4 there. There's going to be something in the original question that allows you to write an equation. We have our chart of data now, and now I'm going to go back and I'm going to take out my highlighter and see where it is in the original question that gives me a hint how to write out the equation, and that hint is right here. His total driving time was 10 hours, which means that this driving time plus this driving time, and I'll start writing that out, 360 over x plus 360 over x plus 30, those two have to total 10. And I'm going to leave some space after the second one, because now this is a rational equation. I can make a 10 over 1. And we solved rational equations yesterday and the day before. The strategy was, first, get a common denominator, and then you can multiply to get rid of that denominator. So here, with the x and the x plus 30 and the 1, well, this x plus 30 would be grouped together. This first one's missing an x plus 30. So I multiply top and bottom by x plus 30. The second one is missing an x. And the third one is missing an x and an x plus 30. And once you have that common denominator, you can multiply both sides by that, and all your denominators will go away. And then we write what we have left. Well, if I multiply this out, x times 360, that's pretty easy mental math, 360x, but 30 times 360, not so easy mental math. What do we get there? 10,800. So this would definitely be a calculator question. And then plus another 360x equals, and on this side, we would have 10x times x would be 10x squared, and 10x times 30 would be plus 300x. That gives us a quadratic equation. How do you solve quadratic equations? Make one side equal to 0. I would probably make the left side equal to 0 because I like whatever's in front of my x squared to be positive. So I have a 10x squared. I'm going to combine my like terms. 360 plus 360 is 720. When I move it over to the other side, I get negative 420x. And moving the 1080 over to the others, or 10,800 over to the other side, I get this equation. And to solve this, we either have to factor or use the quadratic formula. Personally, though, I would first notice, hey, there's a common factor of 10. You can either factor that common factor of 10 out, but since it's an equation, you can actually just decide to divide everything by 10. You divide everything by 10, you still get 0 here. This would be x squared minus 42x minus 1080. At this point, I would probably recommend for this question using your calculator and using the quadratic formula. It's going to have some big numbers, like b is 42, so when you get to the b squared part, it's going to have some big numbers. Okay? If you wanted to, you could factor this one. So I'll show you with factoring. Probably don't know that 60 times 18 is 1080. And 60 minus 18 is 42, so it looks promising. This part of the factoring, I think you probably were pretty good at. Oh, I got the x and the x. But if I need a negative 42, does it make sense? My inside would be negative 60, my outside plus 18, which gives me x equals 60 and x equals negative 18. Now we're trying to solve for speeds, and in word problems, you should always sort of write a statement in the end. Make sure you include your units. I hope you can see that this answer is impossible. You cannot be traveling negative 18 kilometers per hour to get somewhere.
Is that like time traveling?
That's like going, yeah, maybe backwards in time. Yeah, I was there 5 hours ago. Perfect. Yeah, if I leave now, I got there last night. Wonderful. So, we can write our final answer from Edmonton to Grand Prairie is 60 kilometers per hour, and from Grand Prairie to Edmonton, he was traveling 30 kilometers faster. That would be 90 kilometers per hour. And that would be the final answer. So this one, the numbers are big. Quadratic formula would come into place. They tend to, and I'll give you one on your test where the numbers are smaller and more easily usable. The problem with speeds is if you're talking about a car question, your answers are going to be like 60, 70, 80 kilometers per hour, bigger numbers, right? Maybe he should have rode his bike, and it took him 100 hours to get there, but then our answers would have been smaller numbers, so it would be easier.
Just like a jog.
Yeah. Limped all the way from Edmonton to Grand Prairie, and it took him 72 days. Okay. So with that, we're going to do another one. That's not pretty. We're going to do another distance speed question, but this time we're talking about a boat on water. So again, we start by setting up our chart, and our chart will always have distance, speed, and time. And then we have to think, what are our situations? Boat travels an average speed of 15 kilometers per hour in still water. It travels 12 kilometers downstream. In the same time, it travels 8 kilometers upstream. So we can write downstream and upstream. And the question tells us the distance downstream was 12 kilometers. The distance upstream was 8 kilometers. And we need to find the average speed of the current. So I'm going to introduce a variable. I'm going to introduce the variable x for the current. Does it make sense? Where would you be going faster, downstream or upstream? Downstream would be faster because the current would be with you. So you normally go 15, but downstream you would add your current. Upstream, you would subtract your current. So there's, in all of these questions, there's some thinking involved. What is the situation? What am I going to choose for my variable? How do I apply that in my chart? And then here, again, we can use that time is distance over speed. So distance is 12 over 15 plus x, and this one would be 8 over 15 minus x. Once your chart is completed, there's going to be something in the word problem that gives you a hint how to write the equation. The hint in this one, take up my highlighter, it's kind of small, but it's right there. It's the same time. So this time and this time have to be equal. That lets us create an equation. Because if I make this time equal to this time, now I've got an equation. This is one factor, this is another factor. How do I solve equations? I get a common denominator. In this case, you could use the cross multiplying, okay? But you'll see it with the common denominator, because if I get my common denominator, this one's missing the 15 minus x, and this one's missing the 15 plus x. And then if I multiply to get rid of my denominators, all that's happened is you have, in this case, cross multiply. But it's good to show this work, because if you use this strategy all the way through, you're never going to accidentally use cross multiplying when you're not allowed. So if I multiply these out, 12 times 15, that's 180. 180 minus 12x equals 120 plus 8x. And combine my like terms, so I'll put 120 on this side, will give me 60, add 12 to that side, will give me 20x, divide. Because it's a word problem, make sure we include our units, double check, was it kilometers per hour, not meters per second? It was kilometers per hour. So the current is 3 kilometers per hour. Circle questions 8, 11, 12, and 13.